Good afternoon, everyone present. We are Group 22 from the batch of 2019. I am Sampath, and we have my teammate Christopher and Mohit along with me. Our topic of presentation is reduction smelting using a shaft furnace. The contents of our presentation are as follows. Firstly, we'll present a background guide and then introduce you to the concept of smelting, followed by its types, and then a conventional method that is carried out in a blast furnace along with a video description. Later, we'll give you a glance of reduction smelting, the topic of the day, the basics of reduction smelting, and some history about it. We will then look at the process of reduction smelting using a shaft furnace, an innovative modern technology, its applications, and another video description of how things work. Starting off with the introduction, smelting is one of the fundamental extraction processes that dates its roots to the 5000 BC. Apart from its usual definition of melting metal out of the ore, it is a process relied by the industries for more than one purpose. Our topic of discussion, reduction smelting using a shaft furnace, which came to light in the last century, is one of the most advanced technologies as it facilitates large-scale production at a cheaper cost. Moreover, this invention enables the occurrence of some of the most difficult thermodynamic processes very easily. So now that smelting is altogether a new era in the industry and we know a lot about it, let us know what is smelting. So smelting is a unit process of heating a mixture of ore concentrate and flux along with fuel, if necessary, above the melting point of the metal. The prime motor behind this process is the separation of gangue mineral from ore in liquid state. During this process, the physical state changes from solid to liquid and gases. Some commonly seen examples are extraction of pig iron from iron ore and extraction of zinc from zinc ore. Moving ahead, let's see the different types of smelting. We have three different types of smelting, and they are met smelting, reduction smelting, and flash smelting. Firstly, the met smelting is a unit process of heating a mixture of ore concentrate and flux along with fuel, if necessary, to produce matte. Here, met is a molten metal sulfide used to collect impurities insoluble in metals and slag. The reaction is given as follows. Copper ore concentrate plus flux plus air plus heat plus fuel, if necessary, gives met, slag, and gases. Now, another type of smelting, another branch of smelting, that is flash smelting. This is an upgradation of smelting processes where the end products are effectively utilized by the injection of dry concentrate and flux along with hot air. And the best example being the conversion of sulfur dioxide end product to sulfuric acid. Our important type of smelting, another type of smelting, that is reduction smelting, is discussed in detail later in the course of the presentation. Moving ahead with our discussion, since smelting is a process that requires extremely high temperatures to heat the concentrate to get desirable results, a specially designed furnace called blast furnace is used. The schematic diagram of the blast furnace is given here. Starting from the injection of iron ore and limestone sinter coke at the feedstock inlet, to the process of separation using different types of separators like the cyclone separator, to the removal of slag, and finally the achieving of desirable results, we have a video describing the entire working process of a blast furnace. Let's have a look at the video. Here's the video.
The blast furnace is a huge furnace used to extract metals from their compounds using a suitable reducing agent. It is a tall chimney-like structure about 30 to 40 meters tall and about 10 meters wide at the base. It is narrow at the top, increasing in diameter downward but narrowing again near the bottom. The bottom portion is called the hearth. It is lined with fire-resistant bricks. At the top of the furnace is a double cup and cone arrangement. This arrangement is used for the introduction of the charge, which is a mixture of coke, concentrated iron ore, and limestone. The furnace has three outlets, an exhaust gas outlet at the top for the hot waste gases, and two outlets at the base for discharging molten metal and slag. The gas discharged from the gas outlet is passed through a dust catcher to remove suspended particles and then fed to the stoves to heat the air that is blown into the furnace. At the bottom of the furnace, there are two nozzles called tuyers, through which hot air is blown into the furnace. This process is called blasting, and that is why the furnace is known as a blast furnace. Extraction of iron from blast furnace. At the end of this module, you will be able to describe the working of a blast furnace, Let us now find out how iron is extracted from its ore in the blast furnace. Before the ore can go into the furnace, it has to undergo certain preliminary treatment like concentration or dressing and roasting or calcination. Iron ore mined from the earth's crust contains impurities such as sand, rocky materials, limestone, etc. The impurities are collectively known as gangue. The gangue must be removed before the metal can be extracted. The process by which impurities are removed from the ores is known as concentration or enrichment. To begin with, the ore is crushed into small pieces in a crusher. The crushed ore is then powdered in a grinder or pulverizer. The powdered ore is then washed in a current of water to remove impurities. The heavier ore particles settle down while the lighter impurities are washed away with the water. The concentrated ore is then subjected to a process known as calcination. The ore is heated strongly in the presence of air in a reverberatory furnace. Besides converting the non-oxide compounds in the ore to the oxide, roasting helps in removing moisture and organic matter. Impurities such as carbon and sulfur are converted to their volatile oxides which escape. In addition, ferrous oxide present in the ore is oxidized to ferric oxide. Let us now see how iron is extracted from the roasted iron ore. The process of extraction of iron from its ore is known as smelting. The roasted ore is mixed with coke and limestone. What roles do coke and limestone play? Coke functions as the fuel, at the same time gets converted to carbon monoxide required for the reduction of the ore. The limestone acts as a flux. A flux is a chemical substance which combines with impurities and forms a fusible slag. The charge is brought by trolleys or skip cars over a conveyor system and introduced into the blast furnace through the cup and cone arrangement. Simultaneously, a blast of hot air is blown into the furnace through the two ears at the base of the furnace. The hot air causes the coke in the lower regions of the furnace to burn, producing carbon dioxide and a large amount of heat. This region is called the zone of combustion, as the combustion of coke takes place here. The temperature in this region reaches around 2000 degrees Celsius. The carbon dioxide rises and reacts with the unburned coke to form carbon monoxide. At the same time, the heat causes the limestone present in the charge to decompose and form quicklime and carbon dioxide. The reduction of carbon dioxide and the decomposition of limestone are endothermic reactions. Owing to this, the temperature of this region falls to about 1000 degrees Celsius. Calcium oxide or quicklime fuses with impurities such as silicon dioxide to form liquid calcium silicate or molten slag. The slag flows to the bottom of the furnace and floats on top of the molten iron. This is tapped periodically into ladles for disposal. Since molten slag is produced in this middle region, this region is called the zone of fusion. The temperature of the upper region of the furnace is around 400 to 700 degrees Celsius. In this region, the descending charge is exposed to the action of carbon monoxide streaming up from the lower part of the blast furnace. Carbon monoxide reduces ferric oxide to iron. The iron so produced is a spongy porous solid. As reduction of iron oxide takes place in this region is called zone of reduction. As the iron descends down through the hotter regions of the furnace, it melts. Lower down the furnace, where the temperature is high, any unreduced core is reduced directly by carbon. The molten iron collects at the bottom of the furnace and is tapped periodically. It is poured into sand molds and allowed to cool.
Yes, that is the video description of working of a blast furnace, where you have seen how smelting takes place. As already seen in the schematic diagram in the video description, the image on the right side of this slide is a blast furnace, and it is a universally used furnace in the process of reduction of iron ore, zinc oxide, and lead oxide. As already mentioned, a sintered or pelletized feed consisting of coke as fuel and limestone as flux is charged into the top of the furnace along with iron oxide through a double bell rotating chute, and hot air is blown through nozzles. In this method, combustion occurs as oxygen in the air combines with carbon in coke to generate heat to melt the furnace charge, and ultimately forming carbon monoxide when iron oxide reduces to metallic iron. Also, the carbon monoxide is prevented from escaping, is recovered and burnt as fuel to heat URI air. Now, ultimately, the molten slag and iron are collected in two layers at the bottom part of the furnace with lighter slag at the upper layer, and this finally facilitates the periodic drawing of slag and iron, where slag is discarded and iron goes into getting refined into steel. Although blast furnaces have been in use since many centuries, there are ample of disadvantages associated with it. And the disadvantages are as follows. That is, the extensive requirement of coke in the blast furnace makes the natural resources of coke depleted. environmental concerns in the form of pollution. And this process is also a long one, which consumes high amounts of energy, resulting in lesser yield. And all these disadvantages that have been discussed pave way for more sophisticated, industry-friendly, economical, and efficient process called reduction smelting using a shaft furnace, which will be explained during the course of the presentation by my teammates. Thank you. Now you can take over, Mohit.
Thank you, Sampath. Now we will be understanding about reduction smelting. Next slide, please. So, smelting reduction is basically compilation of two independent unit process, that is direct reduction and smelting. The ore is first reduced with a reducing agent like carbon, and then smelting process is done, which is nothing but heating of the ore and flux to a temperature above its melting point to separate the liquid metal from the slag. Next slide, please. Now, let us have a look on a brief history about the smelting reduction process. So, the first smelting reduction process came into light on 1972 in Sweden in the form of INRED, that is intensive reduction. Intensive reduction was basically a novel concept of producing hot metal of blast furnace quality at a very rapid rate. It was two-stage reduction process in which firstly the reduction of iron oxide to FeO takes place, and then in the second stage reduction of FeO to Fe takes place within a single reactor. This step consumed about 90% of the total process energy, and in the final reduction was carried out in the electrical heated furnace that form the lower part of the reactor, which generally supplies the balanced energy in the form of electricity. Next slide, please. Now we will look on some fundas of smelting reduction process. As we know, smelting reduction is a generally smelting plus reduction process, which is simply melting accompanied by chemical reactions. In an ideal smelting reduction reactor, all the reduction reactions should take place together in the liquid in a single step. In actual practice, for effective process control, most smelting reduction process utilize two reactors. So if we just have to conclude smelting reduction in one sense, it is basically two-step process in which firstly the removal of oxygen takes place from the metal oxide in solid state in varying stages, and then in the second step removal of remaining oxygen takes place in the liquid or molten state. Uh, Here is a schematic representation of smelting reduction technology, where the pre-reduction chamber is filled with iron ore pellets along with fuel, which undergoes combustion, and post this process, the final reduction takes place. Further, the charge is melting using blowers along with the presence of coal, oxygen, or air in the lower chamber that is the smelting reduction vessel. Now, speaking of the challenges, smelting reduction process consume large amount of reductant such as coal. Export gas for power generation is required. Stop and start of this process is done at ease, unlike the blast furnace. Next slide, please. Now, why was shaft furnace required? In brief, if we say because of the following reasons. Firstly, it uses iron oxide feed, which is preferably those not acceptable for traditional blast furnace iron making. Secondly, coke or high-grade iron oxide is not used as feedstock. Thirdly, it is much economical compared to blast furnace iron making, as it uses less expensive raw materials such as low-grade fine ores, iron-bearing plant waste, etc. as the iron oxide feedstock, and non-coking coal, and uses carbon-bearing fines and other inexpensive materials as the reductants. Next slide, please. Now, this is what a shaft furnace looks like. you all can see the various part of the shaft furnace. The main component of shaft furnace comprises of the top, through which the charge is loaded and the gaseous combustion products are discharged. A shaft equipped with two ears through which either a blast for fuel combustion or hot gases are supplied, and an inside crucible with the with a refractory lining where the molten products are collected. The smelt are tapped through an outside crucible or directly from the inside crucible to a forehearth for the stripping of the slags. The forehearth is often equipped for electrical heating. Next slide, please. Let's talk about the working principle of the shaft furnace. Moderate velocities of the gaseous combustion products are the characteristics of this process using shaft furnace. At such velocities, the bulk charge is not entrained by the ascending gas stream, in contrast to case in blast furnace. However, here the principle involves the concurrent motion of charge from top to bottom and of gas force through the charge bottom to top, and of gas force through the charge gases result in good heating exchange and generation of low temperature exhaust gases. Now from here Christopher will carry on the presentation.
Thank you, Mohit. Moving ahead with the most important aspect, that is the advantages of the entire process of reduction smelting. Firstly, this process in comparison with most other processes has high thermal efficiency and consequently higher output due to the high transport rate owing to convention. It is feasible continuous operation suitable for large scale operations in an economical way. Moreover, the reaction rate here is directly proportional to the square root of gas flow, and therefore the availability of gas for reduction increases. And finally, the evaporation cooling enables us to reduce the heat produced at high temperatures. Next slide, please. Now that we know the working principle and advantages, let's see the application of reduction smelting in a shaft furnace. KOREX process, which is the first ever commercial process popular in India, Africa, and Korea, involves the pre-reduction in a shaft furnace. AISI process, developed by American Iron and Steel Institute, also involves a pre-reduction process in a shaft furnace. However, KOREX process is the most efficient, economical, feasible process that involves reduction smelting using a shaft furnace. Next slide, please. Here, a video of the KOREX process.
KOREX is an innovative iron-making technology which is characterized by its economical and environmentally friendly operation. This is made possible by the unique design of the plant. A key feature of the KOREX process is that iron production is carried out in two separate reactors. In the reduction shaft, iron oxides are first reduced to direct reduced iron. Melting of the DRI is then carried out in the melter gasifier. Coal charged to the melter gasifier is gasified, providing the energy for melting as well as the reduction gas.
That's all from our side. These are few references used by our team. Next slide, please. Thank you for listening to us patiently.
Thank you, sir.